Okay, so on Monday, I made a completely total mess of graphing piecewise defined functions. So I'm going to give it another try today, and hopefully I do a better job. So let me open my calculator. Okay, so we're good to go. So I'm going to graph this function here. The PowerPoint will pull up. And it's a piecewise defined function because the output of my function is defined using different equations based on where I'm at in the domain. So for example, if my input x is somewhere between 0 and 3, not including 3, I use the 5x plus 2. For example, if x were 0, I would use this part of the function to evaluate the function. So f of 0 would be what, 2? If x is bigger than 3, let's say it's 4, then I use this part of the function to evaluate my output. So f of 4 would be what, 4 cubed, which is 64. So I use different parts of the function to find the y value, f of x, depending on what my x value is. Now, what does the graph of this thing look like? Well, let's see if I can actually graph it correctly. So I'm going to go over to my calculator. I am going to go over to my calculator, try this again. Here we go. And I'm going to go to my y equals. And I'm going to clear out what I got in there. Okay, so the first part of this function, the y value was defined to be 5x plus 2. And that's for x between 0 and 3. So I'm going to first put the actual definition, the output definition, the 5x plus 2 inside parentheses. So I'm going to put parentheses 5x plus 2, close the parentheses. And now I'm going to use a division symbol here, not because I'm dividing, but because I'm telling my calculator, this is how I tell it, that I am going to graph this for just certain parts of the domain. So I'm going to put a division symbol there. And then I'm going to actually put inside parentheses the criteria for which this function's defined. And it's defined for x is greater than or equal to 0 and less than 3. So I'm going to type that in. So I'm going to type in the first part of this. So it was 0, less than or equal to x. So we're going to type in 0. And then we need the less than or equal to symbol. And I get that. Do you see right here above the math menu? Do you see that? It says test. And that's where I'm going to get that symbol. So I'm going to go second math. And where's my less than or equal to? Is that number 6? So 0 is less than or equal to what? X. So x is greater than or equal to 0. It's also less than 3. So I have to put in the word and. So I'm going to go back to my test menu. And I'm going to go over to my logic. Do you see the next one over is logic? I'm going to go over to logic and I'm going to find the and, which is number 1. So x is greater than or equal to 0 and x is less than 3. So we type in x, go back to the test menu to find that less than. It's number 5. And then close. Better put the 3 in there. Sorry about that. Put the 3 in there and then close the parentheses. So the first part of this function was defined to be 5x plus 2 if X is greater than or equal to 0 and it's less than 3. Okay, now let's type in the second part. So again, I have to use parentheses, and that is X to the third. And I need to arrow out so I can close those parentheses. I have to arrow out of the exponent. And then I'm going to use the division symbol. And then I'm going to type in the inequality. So what was the inequality? If X is between 3 and 5, inclusive. So I'm going to type in the 3. Go find the less than or equal to symbol, which is number 6. Type in the X. So X is greater than or equal to 3, and so now I got to go find the and, which is in my test logic, number 1. And it's what? Less than 5? Less than or equal to 5? So we're going to put in the X, go find the less than or equal to symbol in the test menu, and it's got to be less than or equal to 5. Make sure that I got that correctly. And I think that's correct. Let me make sure. Okay, and I have no idea what my window looks like. I don't know the last time I graphed. I'm just going to do a zoom standard just to reset my window to that standard window. And I'm missing part here because that second graph, the X to the third, is so far up there. I need to adjust my window. So I said I adjusted it from 0 to 5. And from 0 to 125. And I did it by 25. I do believe I matched the window that they have. Okay, so you can see the two parts of the graph here. For X between 0 and 3, we use the line, the linear function to define this function. So when X is 1, Y is 7. When X is 2, Y is 12. When X is not quite 3, it's 17. So this part of the graph, we have a solid dot over here, but we have an open dot over here. And you can't see that on your calculator, but there is an open dot on the right-hand end of that blue line because my domain was defined to be what? X is greater than or equal to 0, but less than 3. So there's an open dot there. Now, the second part of this graph is defined using the cubic function, and it is between 3 and 5 inclusive. So right here, there is a solid dot. Now, you can't see that on your calculator, but there is a solid dot there because the domain was defined to be X is greater than or equal to 3, and it's less than or equal to 5. So when X is 3, Y is what, 27? And when X is 4, Y is 64. So you get this kind of taking off business. But that is what the graph looks like piecewise. Again, what you can't see here is there's an open dot here. There's an open dot right there. And it's an open dot because of the way the domain is defined. The domain is defined to be less than 3. And then the second part of the graph, both parts of the domain definition have less than or equal to. Since it's equal to there's going to be solid dots on each end. Okay, so if we went back and looked at our PowerPoint, this is what the graph looks like. As described for the first part of that graph, where we are using the 2x plus 5 definition of y, there's solid dot on the left-hand end and an open dot on the right-hand end. Because the right-hand part of that inequality is less than, not less than or equal to. And then in the second part of the graph, there's solid dots on each end, because the inequality, the way the domain is defined, we're using less than or equal to, so each endpoint is included. So there's a solid dot on each end. And that is how we graph these things. It takes a little bit of work to graph them because you have to type in the, you have to punch in the domain, but it's a really good way of graphing them. Okay, so let's look at wind chill factor. Wind chill factors, which we're going to have Saturday morning. Does anybody ever go to the Czech Fest?
We're like 35.
No. I said, I don't know that I'm ready for it. Well, as soon as the sun comes out and the parade starts, it'll be. Wind chill factors are used to measure the effect of the combination of temperature and wind speed on human comfort by providing equivalent air temperatures with no wind blowing. One formula that gives the wind chill factor for a 30 degrees Fahrenheit temperature. So your temperature here is constant, it's 30 degrees Fahrenheit. And a wind velocity V in miles per hour is. So the wind chill is defined 3 different ways. If the velocity of your wind is between 0 and 4, including 0, but not including 4, the wind chill factor is 30. So if the wind speed is between 0 and 4 miles per hour, the air temperature feels like the air temperature. It feels like it's 30 degrees. But as soon as you go above that 4 miles per hour in velocity, you have a different formula calculating the wind chill. So as soon as it goes above 4 miles per hour, you start feeling it. So the second we go above 4, and anywhere between 4 and 56 miles per hour approximately, we're going to define the wind chill by that second part. And then if it's above 55.9 miles per hour, it's just cold. Anything above 55.9 miles per hour in wind, it feels like it's minus 6.5 degrees Fahrenheit. It feels really cold. And it doesn't matter if it blows any harder, it still feels that cold. All right, so let's see if we can't calculate a few things. Find the wind chill factor for 30 degrees Fahrenheit. If the temperature, if the wind is 40 miles per hour. So what does it feel like if the velocity of your wind is 40 miles per hour? So what part of this function do I have to use to find the wind chill factor? What's that? The middle one. I have to use the middle one because my wind velocity is between 4 and 55.9. It's 40. So I'm going to use the second part of this to find my wind chill factor. So my wind chill factor is found by taking 1.259 times my velocity minus 18.611 times the square root of my velocity plus 62.255. So I'm going to plug in 40 for my velocity. So my wind chill factor is going to be 1.259 times 40 minus 18.611 times the square root of 40 plus 62.255. Okay, so I am going to go open up my calculator. And I'm gonna do this calculation. So I have 1.259 times 40 minus 18.611 times the square root. So my square root symbol is above my x squared, the square root of 40. And then I need to arrow out of that square root so that I can continue my calculation, plus 62.255. And the answer is minus 5 degrees Fahrenheit. I think they ask you to round that off to the nearest degree. So to the nearest degree, the temperature is minus 5 degrees. That's the wind chill factor, is minus 5 degrees Fahrenheit. So when the wind velocity is 40 miles per hour, the wind chill factor is minus 5 degrees Fahrenheit. Feels cold. Okay. Find the wind chill factor for 30 degrees Fahrenheit temperature if the wind is 65 miles per hour. So what's the wind chill factor if the wind is blowing at 65 miles per hour?
Negative 6.5.
Negative 6.5. Anything above 55.9 is just cold. Feels cold. All right, and then they tell you to graph this. So again, I'm going to graph this using my calculator and the technique that we just went over. I am going to adjust my window to kind of try to get all this stuff in here. Okay, so let me go over to my calculator. Let me go to my y equals and let me clear out. I always hate to clear out all that hard work. I don't know about you guys. All right. So the first part is that y is 30 if x is between 0 and 4, including 0, but not including 4. So I'm going to type the 30 inside parentheses. So for that first part, it's constant. And then I'm going to put the division symbol and then open the parentheses again and type in that inequality. So I have x is greater than or equal to 0. So 0. Go to my test menu, which is above the map, and find number 6. So when x is greater than or equal to 0 and it's less than 4. So I'm going to go find my and in my test menu, logic. Number 1. And it's what, less than 4? So x is less than 4. Does that look good? Does that look good to you? All right. So the second part of this, the y2, is going to be that second part of the function. So again, I'm going to put that in parentheses. 1.259. Excuse me. X. A tickle in my throat. Minus 18.611 times the square root. So go find my square root symbol of x. Now we're going to arrow out of there. Plus 62. Okay. 62.255. So we're going to close those parentheses. Now I have the equation in, and we're going to put in the domain. So the division symbol, open parentheses, and this is between 4 and 55.9 inclusive. So we're going to put the 4, the less than or equal to symbol, Go to the logic menu, second test, logic end. And then X is gonna be less than or equal to 55.9. X is less than or equal to 55.9, and then close those parentheses. So X is between 4 and 55.9 inclusive. And then the last part of this was that it's -6.5 degrees wind chill, correct? If X is greater than 55.9. So in parentheses, put the -6.5. Close those parentheses, use your division symbol to tell your calculator you're going to graph it over a certain interval in the domain. And that is for X is greater than, so go find the greater than symbol, which is number 3. And that's 55.9. Okay, I think I have it correct. And I am going to adjust my window in the X direction. My wind speed can get up to 55.9. The domain can go up to 55.9. So I'm going to go 0 to 70. And I'm just going to change my scale to 5. And then my wind speed, what was my maximum wind speed? Well, my maximum temperature was 30, I think it was. So I'm going to do -10. What was our wind chill can go from what, -6.5 to 30? Was that the top one? So I'm going to go from -10 to 30 by 5 again. So what yours looks like. So anywhere between 0 and 4, the wind chill is constant. It feels like the air temperature. It feels like it's 30 degrees. And then what happens when the wind speed picks up? What happens to the wind chill factor? Does it go down? So the wind chill gets more negative as the wind speed goes up. And we know that for a fact, correct? The higher the wind speed, we live in Oklahoma. The higher the wind speed, the greater the wind chill factor. I have been in Minnesota in January, by the way, when the wind chill was -60 degrees Fahrenheit. You walked out of the airport and you went, ooh. So I have been there. But anyway, so the wind chill, it feels colder as the wind speed picks up. And eventually, it doesn't matter what the wind speed is, it continues to be -6.5 degrees in the wind chill factor. Okay, there is a hole at the end of that blue line because X cannot equal to 4. There's a solid dot there, and it goes to a solid dot down here. And then the black part of my line, there's an open dot on the left-hand side, and then it just continues. It's kind of spiffy. Okay.
How do you know if it's an open or closed dot?
It depends on if it has the equal or not. So for this particular one, because we have B is greater than or equal to 0, on the left hand end at 0, it's a solid dot. The right hand side is greater than, or excuse me, less than 4. Since there's no equal there, it would be an open dot. So it's going to be solid dot, open dot, constant. And then the second one, they're both equals. So you're going to have 2 solid dots on each end. And then the last part, B is greater than 55. So on that black part of my graph, it's open on one side and then it just continues on forever. Now, you can see that they drew this continuous because there's an open dot on one side and a closed dot right on top of it. So since there's an open dot and a closed dot, it's a closed dot. And since you go down and at 55.9, it's a closed dot on one graph and an open dot on the other. Open and close make closed. Okay, so what's the domain and range of this function as graphed? So the domain is all the possible values of x. So, well, in this case, d. What's the domain of this function then?
0 to 70.
0 to 70. Oh, what did you say?
To infinity.
No, it's actually stopping at 70 because of the way they told us to graph it. Yeah, I would agree with you that it technically would be infinity. But the way they told me to graph it, they told me to stop at 70. So I have some issues with that. So an interval notation, is that from 0 to 70? I mean, if you've got wind speed above 70, you're gonna blow away anyway. What's the range? This is the domain. What's the range? That is correct. The smallest value for the wind chill is -6.5. The largest value for wind chill is the air temperature if there's no wind speed. All right, let's look at a step function real quick. We've already seen a step function. In your slide deck, there are 2 slides talking about the greatest integer function. I hid those. I cannot see that you have any homework, and it's confusing as all get out. So I just removed it. You don't have any homework on it, I'm okay. All right. The cost of weekend service calls by AirTech services is shown by this graph. Write a piecewise defined function that represents the cost for services during the first 5 hours as defined by the graph. Okay, so I'm going to call this cost. And in the first hour, what is the cost for service? What's the y value when x goes from 0 to 1? 330. And this is for x is greater than 0, and it kind of makes sense that it would be x is greater than 0 because time would work that way. Time equals 0 is this instant, and then it's not 0 anymore. And then it's going to be what? Less than or equal to 1. And it's less than or equal to because on the right-hand side, you have a solid dot. So you have an open dot on the left-hand side, so you're going to have just greater than or less than. And then on the right-hand side, you're going to have a solid dot. You have a solid dot, so you're going to have less than or equal to. Okay, then what happens to your cost in the next hour? Does it jump up to? And that's from where? From 1 to 2? Then what does it do? Does it jump up again? And that's for what? Between 2 and 5? All right, the last topic in this section is absolute value. Because absolute value is actually a piecewise defined function. And he doesn't tell you that, but it is. Because of the way it's defined. If A is less than 0, if A is negative, then how do you find the absolute value? Well, when you find the absolute value, you just make it positive, correct? But if that number inside those absolute value bars is a negative, you actually change its sign, correct? That is what you do. So the absolute value of A is negative A if A is a negative number. You change its sign, and that's what that means. You change its sign if A is negative. That's what you did. Also, absolute value is defined to be the distance a number is from 0. Since distance is always positive, the absolute value must also be a positive quantity. Okay, but if A is 0 or positive, how do you take the absolute value? You just take the number. So the absolute value of 4 is just 4. So if you take the absolute value of a negative, you change its sign. If you take the absolute value of a positive, you just take the absolute value bars and go on. Okay, and so we use this definition to solve absolute value equations. So I have x minus 3 equals 9. Absolute value of x minus 3 equals 9. Okay, let's pause and ponder this for a minute. What numbers can you take the absolute value of and get 9? What's that?
9.
9 and negative 9. So are there two numbers that I can take the absolute value of and get 9? One of them is negative 9, the other is positive 9.
It would be -6 and 12, right? That would be my answers.
Yes. You said -6 and 12. Did you just figure that out by looking at it?
Yeah.
So are there two answers to this? -6 and 12? Because if you put in -6, -6 minus 3 is -9. The absolute value of -9 is 9. If I put in 12, 12 minus 9 is, 12 minus 3 is 9. The absolute value of 9 is 9. Okay, so what has to be true? And I tell you what, I have seen, and I yell at an algebra class absolutely every semester. I say, I know you want to do it the way you want to do it the way I'm telling you to do it. Are you listening? Let's do it the way I tell you to do it. Did you see what I highlighted in there? That could be -9, correct? Because what I highlighted is what you're taking the absolute value of. It could also be +9. So how do you solve an absolute value equation? You take what you're taking the absolute value of and you set it equal to the negative. You take that and you set it equal to the positive. So you take the x minus 3, it could be -9. It could. And you take the x minus 3 and you set it equal to +9. So you take what you're taking the absolute value of, you set it equal to the negative, you set it equal to the positive, and you solve the resulting equations. And you should always check your solution. You already told me what the solutions are. The solution's -6 and 12. So we already know what's going to work here. And we can prove that by solving the two equations. So do those two numbers satisfy this equation? Are they the solution to this absolute value equation? Do you typically get two solutions? You do, there are exceptions to getting two solutions. One of which, if that constant was zero. And the other exception would be if that thing over there on the right-hand side contains a variable. If it contains a variable, you may only get one solution. But you do have to check them. You need to check both of them. So how would I solve this next one? Maybe not as easy for me just to look at and figure out. Well, maybe I could figure it out. But you're gonna take what you're taking the absolute value of, which is 2x minus 4. You see that? That's what you're taking the absolute value of. And you're gonna set that equal to -8, because can you take the absolute value of -8 and get +8? And you're gonna take that and you're gonna set it equal to +8. You take what you're taking the absolute value of, get rid of the absolute value symbols, set that equal to the negative and set that equal to the positive, and then solve the resulting equations. So what are my two solutions? -2. I think that works. How about the other one? Is that 6? Do a quick check, put -2 in there. 2 times -2 is -4, -4 minus 4 is -8. Absolute value of -8 is +8. How about 6? 2 times 6 is 12, 12 minus 4 is 8. Hey, how about this one? What's inside those absolute value bars? A quadratic. But how do I solve this? I take what's inside the absolute value bars. The x squared minus 5x. I set that equal to -6. I set that equal to +6. And you have two quadratics to solve. This is chapter 2. I don't care how you solve them. Well, actually, we did this earlier in this chapter. Sorry about that. So I'm going to move the -6 over here by adding it. And I'm going to factor it. Since the middle term is minus and the last term is plus, which my husband pointed out to me the other day, he was factoring for me. He goes, have you told him if the middle one's minus and the last one's plus, that they both have to be minus? And I said, I thought of that. Thank you. Since that's minus and that's plus, they both have to be x minus. And I need two factors of 6 that add to 5. What are two factors of 6 that add to 5? Okay, so is that going to be x minus 2, x minus 3? So I have x minus 2 is 0. Or x minus 3 is 0. So do I have x is 2 or x is 3? So do both of those work? 4 minus 10 is 4 squared is 16 minus 10 is 6. It works. 9 minus 15 is -6. That works. Okay, let's try this one. I'm going to move this over here by subtracting it. And now, since that last term is -6, I need two factors of -6 that add to -5. Is that correct? -6 plus 1 is -5, okay. So what are my two solutions? 6 and -1. So I got 4 solutions. I think they all work. 36 minus 30, yep, that works. 1 plus 5, that works. So the solutions are 2, 3, 6, and -1. 4 solutions to that absolute value equation.
Does it matter what order you put them in?
Doesn't matter what order you put them. Well, that was fun. Don't disagree with me, that was fun. Chances are not gonna finish this today, so I will push your due date out. And finish it up on Monday. This is all calculator. Except for the first problem. The rest of them are all calculator. Find the exact quadratic function that fits 3 points on a parabola. And this is probably the hardest thing that we do in this entire section. Because you're gonna have to solve a system of equations, which was chapter 2, where we solve systems of equations. And then we're gonna model data. That's what we're gonna spend the rest of this section doing. We're gonna model data approximately using a quadratic function. You do have in your stat menu, your stat calc menu, a quadratic regression. That's what we're gonna use. We're gonna model data using power functions. You have in your stat calc menu a power regression. Use the first and second differences and visual comparison to determine if a linear or quadratic function is the better fit to the set of data. So in the previous chapter, as you recall, you were given a bar chart. And you were to determine whether that bar chart fit a linear pattern. And you did that by just looking at the differences in the y's. If that's constant, if the second differences are constant, then you can use a linear function. And then we're going to determine whether a quadratic or power function gives a better fit. We can certainly do that by looking at it. Or we can do that by calculating the correlation coefficient squared, which is called I can't remember what it's called, the something power, I don't know what it's called, but it's got a name. All right. So the first problem. You may not even have a clue how to solve this. A parabola passes through 3 points. 0, 5, 4, 13. And -225. Write the equation of the quadratic function whose graph is this parabola. All right, so I need to remember what the graph of what the equation of a parabola looks like. So the quadratic function has this equation. Y equals ax squared plus bx plus c. And what I'm given is 3 different points, x and y. So I'm given 3 different x and y pairs. So I'm going to plug in each of these XY pairs into my quadratic function and get an equation. So first, 0, 5.
5 would be C, right?
5 is Y, and it will be C. Very good. Already got that figured out?
That's the y-intercept.
Since it's Y and that's X is 0, so when you plug that in, so what do you get? It's 5. Well, that helps me with the other 2 equations. Very good. That's a lot of
Doesn't
insight.
matter that it's the y-intercept?
Hmm?
So it doesn't matter that it's the y-intercept?
It is the y-intercept. That's coincident. I mean, that is what it is. I don't know if it's coincidence, but yes, you are correct. It's the y-intercept.
But it doesn't matter for the purposes of finding.
It will matter when I find the final equation that constant is 5, that constant has to be 5. Okay, now let's plug in 413. So I get 13 equals A times, I didn't make that squared there. A times 4 squared plus B times 4 plus C is 5, correct? Can I put that in there? So what do I get? I get 13 equals 16A plus 4B plus 5. If I subtract 5 from both sides, do I get an equation in A and B? 16A plus 4B is equal to 8. So there's one equation in A and B. Okay, let's find the second equation. So I have that it goes through the points -2, 25. -2, 25. So I have 25 equals -2 squared. A times -2 squared. Plus B times -2 plus 5. C is 5, correct? So what do I get? Subtract 5 from both sides, and I get 4A minus 2B equals 20. So there's one equation. What was the other equation? 16A plus 4B equals 8. I can write that neater. Maybe my pen's giving out on me here. Tip broke. The failure of $100 pencil because the tip broke, and here's the tip right here. That really frustrates me. You can't even see it. I picked it up, little black thing here. All right, so I need to solve this system of equations. I would multiply this top equation by 2. And that is going to make that second term -4B, which when I add those two together will eliminate the B. So I'm going to multiply that. I get 8A minus 4B is what? 40? Add those together. 24A, the B's add to 0 equals 48. So what's A? So the coefficient on my x squared term is what, 2? The constant is 5. So what's B? Pick one of your equations. Doesn't matter which one, so let's pick this one. 4A minus 2B is 20, and plug in 2 right there. So we get 8 minus 2B is 20. Subtract the 8 from both sides. So is B -6? So what's the equation of this parabola then? Two x squared minus 6x plus 5. Okay. Let's start our regression problems. So modeling data using either a quadratic model or a power model. The table shows the revenue in billions of dollars from artificial intelligence for enterprise applications in North America for the years 2016 through 2025. Okay, I'll put this table back up here in just a minute so that you can put this in your calculator. Create a scatter plot of the data with X equal to the number of years after 2015. So first thing we're going to do is create a scatter plot of this. So let's put the data back up there. And you want to put in your first list the years after 2015. So what are you going to put in? 2016 is how many years after 2015? 1. So in your first list, L1, you're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And in your second list, you're going to put the revenue in billions of dollars. Okay, so why don't you get started doing that? Sorry, I put that in your way. I'm gonna move it over here. So I can go put it in. So we go stat, edit, and then put it in your lists. I messed up. I messed up here. I can fix it. I will fix it. Just a second. Finish this. Oh, it's 11. Nine, 5. Okay, so if you're looking up here, you see I made a mistake. I put 6 and 7 there, but I can fix that by doing an insert. So I'm gonna go back over here and I'm gonna go up to that place. I'm gonna change that to 6. Then I'm gonna go down and I'm gonna insert a row. So I'm gonna go second insert. And I'm gonna insert that 7. So now I should be good to go. So I could insert a row using insert. Isn't that convenient? I'm gonna make sure I have this in here correctly. Okay, that looks good. Looks like that I have it incorrectly. So I went stat, edit. I put my years in my first list and this revenue in billions of dollars in the second list. So now I'm going to draw a scatter plot of this. So I have to go in here and clear out my y equals. If I have something in there, I'm good there. If I have something in the y equals, I don't want it to graph. So I'm gonna clear that out. Okay, then I'm gonna go up to my stat plot, second y equals, and none of my plots are on. So I'm gonna turn on that first plot by clicking on the enter and then highlighting the on and hitting enter. And the first plot is the scatter plot and it defaults to the first two lists, L1 and L2. So I'm good to go. So to graph this, I'm gonna do a zoom stat, zoom 9. And that will set my window appropriately. It will set my window to fit my data. So I'm gonna go zoom 9. And there we go. What's that look like to you? That looks quadratic to me. Why does it look quadratic? Does it have that kind of bowl shape, at least half of a bowl? So this data looks like it fits a quadratic model to me. Okay? That is my opinion. So what's the second part of this? Find the quadratic function that is the best fit for this data. With x equal to the number of years after 2015. All right. So I'm going to go back to my stat menu, my statistics menu. And I'm going to arrow to the right to the calculate menu. And I'm going to look through this menu. We've used number 4, linear regression. What's number 5? Quad. It is a quadratic regression. It will fit your data to a quadratic model. It's not number 7. Number 7 is quart. That's to the 4th power. We want quad to the 2nd power. So we want number 5. And it's going to ask me, where are my list? My X values were in L1. Is that where I put them? My Y values are in L2. Is that where I put those? The frequency list should be empty. If you have anything in there, delete it. I'm going to go ahead and store my regression equation because I bet you dollars to donuts I'm going to have to graph it. So I'm going to go down here to the regression equation line, store regression equation, and I'm going to go find the Y1. Do you remember how to do that? You go to your variables menu, which is just to the left of clear. You go to your Y variables by arrowing to the right. Number 1 is function. So you hit enter and you're going to store that in Y1. So when it calculates this quadratic regression, it's going to store that regression equation in our Y1s. So let's calculate, shall we? Okay, so what does it give you? It gives you the A, B, and C in that standard general quadratic equation. So A, the coefficient on the x squared is what? 0.229 or 0.2289, depending on how many decimal places they tell you to round this off to. B is negative 0.9409. And our constant C is 1.2548. Is that what you guys got? Did everybody get the same thing? Did I do it right? 0.229, negative 0.941, 1.22255. I like it when I do it right. Okay, and what's the next part of this? Graph. Yeah, I knew they're going to make me do this. So does it make sense to always store your regression equation? Yes, because they're going to always ask you to graph it.
How you do that again?
How to store it again? Let's go back over it, shall we? So I'm going to go back into my stat. I'm going to go over to calc. And I'm going to calculate a number 5. Okay? Come on, there we go. Okay, so I need to go find Y1. So I go to my variables menu, which is just to the left of the clear button. Variables. The variables I'm interested in are Y variables, Y equals, so I go to the Y variables. And then you've got choices. We have not talked about parametric or polar. Haven't done that. The only thing we've talked about is functions, correct? So I hit enter and then store it wherever you want to. I'm gonna store it in Y1, so I'm gonna hit enter. And then calculate. Come on, there we go. Okay, so now when I hit the graph button, what happens? Does it graph your scatter plot and your regression curve?
Do that with the line one.
You sure can. You probably should.
Didn't we go over that?
We did,
No, we did.
we did. We've gone over this. Okay, so does this seem like a reasonable fit to you? How's that look to you? Pretty good, I would think. I would think that that's a very good model for this data. All right. Use the model to find the enterprise AI revenue in 2026. All right, so we're looking at X's after 2015. So 2026 minus 2015 is 11 years. So X equals 11. So we want the revenue when X equals 11. What is the easiest way to find this?
Do the value.
That would work very quickly. What's that? The table. Value and table will give you the exact same answer. So if I look at the table, which is above my graph, so second table, can you find X is 11? Well, I need to do a table start here. So I'm going to do a table set, which is above my window, and start it at a more reasonable value. So what are we looking for, 11? And now look at the table. So what is it at 11? 18.604? So did you see that again? My table started at 100, so I can either scroll up to 11, or I can do a table set, which is second window, and set the table to start at wherever I want it to start. And I started at 11 so that I could see that. Now, you are correct, CJ. I could also do this using the calculate. So if I go to my calculate menu, which is above the trace, and I calculate a value at X equals 11, what do I get? I get an error because my domain is not correct. So I need to open up that domain to include 11. So I'm going to go to my window and set my X max to something that includes 11, 15. And then graph it, try it again. Same value? 18 point.
The other one was 18.04, right? This one's 18.6 something.
18.6, no, I think it was the same. 18.604. We got 18.604 for both ways.
I thought it was.
We're good. And you know what? It better be the same or something's gone wrong. Seriously. Let's do another one. Then we'll call it a week. Wrong computer. North American cloud computing revenues from 2008 and projected to 2020 are shown in this table. And all I really need to know to put this in my calculator is how they want me to put in the year. I'm gonna go to the next slide so I can see that. Create a scatter plot of the data points with X equal to the number of years after 2000. So after 2000 would be what, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, 17, 18, 19, 20, is that good? And then put the revenue in a second list. I'm just gonna put it in L1 and L2. I'm done with that data that I just calculated with, so I'm gonna get that out of there. So to clear my list, I can just arrow up to highlight the L and hit the clear. And when I come back down, it'll clear that list out. So I'll go up to the L2, hit clear, come down, and it's clear. So now I'm ready to put it in. Okay, I messed up somewhere. Dang it. Where did I mess up?
17,
What's that?
on 17, you've got 84.
I don't know where that came from. And I was watching it hit enter. 51.8785, 59 points. I still don't know where I messed up though. I'm off by 1. Oh, because I had the 8. 7.8. 9, 9.553, 10, 11.665, 11, 14.568, 12 is 17.831, 13
This
is
is
20.
2018.
What did I miss?
2018 is 45.150.
Okay, let me walk through it. Let me walk through it and see if I can figure it out. $45.15. $51.785 and 59.53. Now am I good? So, okay, so let's draw a scatter plot. And everything should still be good from the prior scatter plot. I just need to do a zoom stat to get the window set. So I'm gonna do a zoom 9. Oh, I have my graph in there, so I'm gonna go clear that out. We'll clear out the y equals. And graph it again. Is that what yours looks like? Does that look quadratic to you? Pretty close. So we're gonna go calculate a quadratic regression, which is number 5. And I am gonna store that in my y equals. And then calculate. Is that what you get? 0.231, negative 2.246, 11.131. It's good. Is that what we got? 0.231, check, negative 2.246, check, 11.131. And then we already graphed it, we can graph it again. Is that a good fit? What's your opinion? I said it's a very good fit. Okay, any questions? All right, we'll pick up here on Monday and finish this up. A few more slides.